Download this code from codegive.com, link in the description below. Java Variable Scope and Lifetime, a comprehensive tutorial. Understanding variable scope and lifetime is crucial for writing correct, maintainable, and efficient Java code. It dictates where a variable can be accessed within your program and when the memory allocated to that variable is freed. Ignoring these concepts can lead to bugs like variable shadowing, unexpected modification, and memory leaks. This tutorial covers the different types of variable scope in Java, their life cycles, and best practices for managing them effectively. 1. What is scope? The scope of a variable defines the region of the program where the variable is accessible, i.e., where you can use its name to refer to its value. Outside of its scope, the variable is essentially invisible and cannot be used. 2. Types of variable scope in Java ***. Java has 4 primary levels of variable scope, ordered from smallest, most local, to largest, most global. Local scope, method/block scope declared inside a method or a block of code, enclosed within curly braces. Loop scope a special case of local scope, specific to variables declared within loops, like for or while. Instance scope, class level declared inside a class but outside any method. Associated with individual objects, instances, of the class. Also known as instance variables or fields. Static scope, class level declared inside a class but outside any method and marked with the static keyword. Associated with the class itself, not with individual objects. Also known as static variables or class variables. Let's delve into each scope type with examples. 2.1. Local scope, method/block scope. Definition variables declared within a method or a block of code, delimited by, have local scope. They are only accessible from the point of declaration until the end of the block or method. Lifetime they exist as long as the method or block of code is executing. When the method or block completes, the memory occupied by the local variables is released. Example explanation outer variable is declared inside the main method and is accessible throughout the main method, including inside the if block. Inner variable is declared inside the if block and is only accessible within that block. Attempting to access it outside the if block will result in a compilation error. Method variable is declared inside the my method and is only accessible within that method. Outer variable is not accessible within my method because outer variable is local to main. 2.2. Loop scope definition variables declared within the initialization section of a loop, example for, int I equals 0, I10, I++, are scoped specifically to that loop. Lifetime they exist for the duration of the loop's execution. Example explanation the variable I is declared within the for loop. It's accessible only within the loop's body and update expression, I++. Trying to access I outside the for loop results in a compilation error because it's outside the scope of I. 2.3. Instance scope, class level. Definition variables declared inside a class but outside any method, constructor, or block, are instance variables. Each object, instance, of the class has its own copy of these variables. Lifetime instance variables exist as long as the object they belong to exists. When the object is garbage collected, the instance variables are also removed from memory. Example Asterisk explanation asterisk. Asterisk name and age are instance variables of the dog class. Asterisk each dog object, like dog1 and dog2, has its own separate copies of name and age. Asterisk modifying dog1.name will not affect dog2.name. 2.4 Static scope, class level. Asterisk definition asterisk variables declared inside a class but outside any method, constructor, or block and marked with the static keyword, are static variables, also known as class variables. There is only one copy of a static variable shared by all instances of the class. Asterisk lifetime asterisk static variables exist from the time the class is loaded into memory until the program terminates, or the class is unloaded, which is rare in modern JVMs. Asterisk example asterisk. Asterisk explanation asterisk. Asterisk count is a static variable of the counter class. Asterisk every time a counter object is created, the count variable is incremented, and the increment is reflected across all instances because there's only one count variable for the entire class. Asterisk you can access static variables using the class name, example counter.count. 3. Variable lifetime, duration. The lifetime of a variable is the period during which the variable exists in memory. It's closely related to the scope but emphasizes the duration rather than the accessibility. Asterisk local variables asterisk lifetime is limited to the execution of the method or block in which they are declared. They are created when the method/block starts executing and destroyed when the method/block completes. Asterisk instance variables asterisk lifetime is tied to the lifetime of the object they belong to. They are created when the object is created, using new, and destroyed when the object is eligible for garbage collection. Asterisk static variables asterisk lifetime spans the entire execution of the program, or until the class is unloaded, which is uncommon. They are created when the class is loaded and remain in memory until the program terminates. 4. Variable shadowing asterisk asterisk. Shadowing occurs when a variable declared within a particular scope, example a method, has the same name as a variable declared in an outer scope, example an instance variable. The inner variable hides the outer variable within the inner scope. Asterisk example asterisk. Asterisk explanation asterisk. Asterisk the parameter x in my method shadows the instance variable x. Asterisk within my method, using x refers to the parameter x, local to the method. Asterisk to access the instance variable x, you need to use the this keyword, example this.x. This refers to the current object. 5. Best practices and considerations asterisk asterisk. Asterisk declare variables as locally as possible asterisk limit the scope of your variables to the smallest necessary region. This improves code readability and reduces the risk of unintended modification or conflicts. Asterisk avoid shadowing asterisk while shadowing is sometimes unavoidable, try to choose distinct variable names to minimize confusion and potential bugs. If shadowing is necessary, use this to explicitly access instance variables. Asterisk understand the lifetime of variables asterisk be aware of when variables are created and destroyed. This is particularly important for memory management and avoiding situations where you're trying to access a variable that no longer exists. Asterisk use descriptive variable names asterisk choose names that clearly indicate the purpose of the variable. This enhances code readability and maintainability. Asterisk static variables, use with caution asterisk static variables can be useful for representing data that is shared across all instances of a class. However, excessive use of static variables can lead to tightly coupled code and make testing more difficult. Consider the design implications carefully. Often, a singleton pattern or dependency injection might be a better choice. Asterisk garbage collection, GC in Java, memory management is largely automatic due to garbage collection. When an object or variable is no longer reachable, i.e., there are no active references to it, the GC can reclaim the memory it occupies. Understanding variable scope and lifetime helps you write code that makes effective use of garbage collection. Keeping variables in scope longer than necessary can prevent GC from reclaiming memory, potentially leading to memory leaks. Asterisk final variables. Asterisk declaring a variable with the final keyword means its value cannot be changed after it's initialized. Final has some subtle interaction with scope and lifetime. For instance, a final instance variable must be initialized by the end of the constructor. 6. Code examples illustrating key concepts. Here are more examples illustrating various aspects of scope and lifetime. In summary, asterisk scope defines where a variable is accessible. Lifetime defines how long a variable exists in memory. Understanding these concepts is essential for writing reliable and efficient Java code. Use local scope as much as possible. Be mindful of variable shadowing. Use static variables strategically. By mastering variable scope and lifetime, you'll write cleaner, more robust, and easier to maintain Java applications. Practice these concepts with different code examples to solidify your understanding. Good luck.